So hello, everyone. My name is Gabriel, and I'm going to talk about automatic query optimization, and specifically what happens when your users do not own their queries. So this is the agenda for this session. We're going to discuss automatic query optimization in general, kind of an overview. We're going to deep dive into the different type of recommendations and change types. And then the challenges when you are not in control of the app code. And finally, some alternatives and ideas of about how to deal with those situations. So a little bit about myself. I started my DB journey back in 2006 as a junior Oracle DBA, as many people did. And then got fully into open source databases around 2014, specifically MySQL and MariaDB. So I have a good experience as a DBA or a DBRE, doing consulting and even some MySQL development. I started building the Tuning Wizard API in October 2022. As you would imagine, it's an automatic query optimization API, and that got acquired by Releem last year. So I'm now helping them to take automatic query optimization to the next level. And with that, we can start discussing query optimization, right? Well, what is it? Well, it's just about finding things to do that can make your queries run faster, right? So queries are the way users and applications interact with database servers. And of course, performance is very important. It might be tied to the performance of your site, or how fast you need some report to be presented, right? So tuning can be done from two different approaches. You can have more like a indirect tuning of your queries, where you're actually improving host and server performance, and then you can do like direct tuning, where you grab a specific query or a specific case, and then you see what can be done for that specific query. So we're going to discuss a little bit about both. Of course, automatic query tuning is usually more about grabbing specific cases, specific queries, and see what can be done for those special cases. So of course, automatic query optimization is about doing all this in an automatic fashion, right? And let's see how we can do that. So you will usually need some sort of agent or process to collect all the context that your optimization engine will need to optimize your query. So of course, the SQL itself, some server details. It's important to know versions and some flavors, because there might be options that are available, tuning options that are available on some versions and or only on some flavors. Schema data is also very important context. You could do some tuning based on best practices by just getting the SQL, but if you really want to get some good tailored recommendations that adjust to your specific case, then schema data is kind of fundamental. And execution statistics, right? About some data about what access paths are used by the server, what indexes are used, how many rows are being retrieved, how many loops are done. So basically, the type of information an execution plan will give you. So all that is fed into this query optimization engine, which again, it's that's a chapter on its own, right? So we're not going to focus about how query optimization is done, but more than what type of outputs it returns. So after that, you're usually going to get two things, right? Findings, so things are not optimal, or things that can be improved on your query execution plan, and what recommendations, which are things that are things that you can do to attack those bottlenecks or those findings. In some cases, these recommendations can be applied automatically, which is great. because you're taking care of the entire workflow from the from the analysis to the implementation. And then you're probably going to measure the impact, right? You want to know, okay, I generated this recommendation, I implemented it. Okay, how much better my query is running, right? In some cases, it might have a great impact. In some cases, it might be negligible. So you need to measure that impact and then decide if you want to keep it or roll it back because it was it was really not making a lot of difference. So that's kind of the overview of the optimization process. When you do automatic query optimization, you want to aim for you want to aim for things that happen silently and transparently, as transparently as possible. So if recommendations are generated, you want the type of recommendations that can be transparently implemented in a way that you don't need to shut down the server or you don't need to change your application. So it's the ideal case is the ideal recommendations are those that can be implemented like using the process I showed you, where like things can be handled automatically and there's no disruption for the system or the application. Usually recommendations can be applied at 3 different levels: host level, query level, and database server level. So let's dive into each one of these. So recommendations at the host level are changes that usually made at operating system level, to remove bottlenecks that could be slowing down the database server. This could also include database upgrades, right? There's some cases where performance is related to database software regressions, and because they you actually need to replace those binaries, so change the server binaries entirely. So they need to happen at the host level, right? Of course, you need to shut down the server to do that. There could be also scenarios where your database server is competing with other processes running on the same host. So either increasing the priority to your database server or removing those other those other services that are competing for resources could be part of things that can be done at the host level. These aren't great for automatic query tuning. I mean, again, think of the process or think of the workflow I showed you before, right? So these recommendations are usually more on the like global tuning or more like server tuning, right? It's not they are not query specific in many cases. So it's just they are more about making the server to run faster or to prioritize its execution or to use more resources or to improve the software by upgrading it. But they won't do much for your specific query, right? Of course, they are operating system specific, so the recommendations they need to be tailored for the operating system your database server is running on. So you need to keep, if you would want to implement that automatically, you would need to keep that in mind. And of course, you usually have limited access to the underlying host, right? So many cases you would need something like root or full sudo privileges to implement some of these changes, and getting that is kind of a bit outside of the scope of your database server or even your automatic query tuning agent, right? So of course, sometimes they can't be executed online, so you actually need to stop and restart the server to implement some of these. So again, not very transparent. And as I said, there might be other services running on the host, so you need to. It's very hard for you to account for that, right? It's kind of it's kind of getting outside of your scope of the database server scope. Okay, so yeah, so let's leave host level recommendations aside for a second, and let's see what query level recommendations are about. These type of recommendations can really make a difference. They require a good understanding of SQL and the steps the database server takes to process a query, right? So the goal here is to perform changes on the query, so it has the same effect or returns the same data, but avoiding those expensive steps like temporary tables or using indexes more efficiently. Changes like hints or session parameters would also fall into this category. And the challenges of these type of recommendations are that when you're doing automatic tuning, you kind of lack of functional context, right? In some scenarios, it's like, I don't know, perhaps it would be useful for your query if another column is included on the word clause. So an index becomes more selectivity improves. But yeah, the question is, okay, yeah, from a technical standpoint, I think that column would help, but from a query standpoint, can you really do that, right? In some cases you can. In some cases, adding another filter will change the the output, and so it's not possible. Same with cases where you have union and union all. Is really deduplication needed? Can you afford just doing a union all and avoid deduplication? Well, again, it depends on your use case. So that's the type of context that you don't have when you're doing automatic query tuning, and that can be a bit challenging when you are generating query level recommendations. But again, in general, you can get some good strategies or things to change and help your query execution time. Of course, in practice, query level changes are only useful when you can change the code, right? When you are in charge of maintaining your application, or you have access to your application code, and you can either override what the ORM is doing and put your own query there, or just change the SQL or the code directly so it generates the query the way you want. That excludes scenarios where, again, the application is closed source, or you have an app that is it's a canned solution, right? So even though the code might be available, it's not really something it's not really part of your business, or you don't have a dev team to take care of that. So you don't really want to get into the WordPress code and start tweaking with the queries. So just to implement these recommendations, again, it's feasible. So that's why I added that star there. But it's feasible, but it's not something you want to do if you don't have someone in charge of the code within your organization, right? So, and these scenarios are very common among small to mid-sized organizations, right? Perhaps bigger shops or bigger companies, they have their own dev team, or they develop their own products, and these scenarios are not that frequent. Okay, so if you're not in charge of your code, then query level recommendations are not good for you. So let's focus on that third group, which is database server level. So changes for this recommendation type only requires database server access, and in most cases they can be done dynamically. So which is a good thing. Transparent for your apps. That's good. That's what you want. That's what your users would want. And in many cases, the changes in this category can drastically reduce the execution time. This is the case for like indexes or partitioning, and also less known scenarios like data types mismatches, producing like full scans on joins, right? So that's another example of things that you can fix at the database server level, mostly without changing anything on data on the app, and getting that additional performance. There's also points around statistics and histograms, which can have they won't have direct impact on the execution time, but they can give more information to the optimizer to produce better execution plans. So you could end up eventually having having better performance. In some cases, the optimizer is operating on incomplete or stale statistics, and when you get that updated or you provide more information like histograms, the optimizer can come up with with a better plan, better execution plan. Server parameter changes, again, they are applied at a global level. So again, they are indirect, but they could, in some cases, they could still benefit specific queries, especially when you are enabling or disabling certain optimizer features. This is one of the most flexible type of recommendations, as I said, right? Just database server access is required. You have that. You have some sort of agent doing that collection of data needed for the query optimization. Many of them can be applied online. As I said, they are transparent to the application in most cases, and they have a good impact benefit ratio, right? Which is something you want. Like you want your changes that are cheap to implement and that they have higher chances of bringing a lot of benefit. There's a caveat, right? There's some cases where recommendations have like two parts, right? They have a database server level change but they also require query level changes. So these, if you're not in charge of your code, we would need to leave these ones outside of the options. So examples of that are full text indexes, even also functional indexes, where you need to generate the index on the database server, but then you need to change, like for example, with full text indexes, you need to change the query to use full text syntax, right? It's not that just creating the full text index is not enough. With functional indexes, there are cases with MariaDB, I think it's before version 10.8, where you create a virtual column and then you using that function expression, and then you index that virtual column. But really, if you don't start referencing the virtual column, the server is not smart enough to say, okay, I have a virtual column that matches this expression, right? We won't do that. So you need to change the code to use the virtual column for the functional index to work. There's also a special case like this alternative or workaround. Like if you want to implement query changes, but you don't want to change the code or the app or the ORM. So if you're using a layer 7 database proxy, like for MySQL, it would be something like MaxScale or Proxy SQL, where queries are changed on the fly, right? So you can create rules within your proxy, and when a certain pattern is matched, then you can inject changes on the query, right? So the modified query will reach the server. So it will be modified. The query will be modified after it leaves the app and before getting into the server. So that would be like kind of a workaround to get query recommendations without changing the code. But again, it depends on your user having this layer 7 proxy installed, right? Like installing a layer 7 proxy just for query rewrite might not be might be too expensive, right? It might not it might be like too hard to sell, right? And then you have an option which is there are some query rewrite plugins where you can add these same rules, but on a plugin running on the database server. So similar to the proxy, once you query certain query pattern is matched, then replaces are done. So you could inject your fixes into that query plugin configuration. Again, this might be simpler to sell, but yeah, again, it might not be available on every database server. And if your users have this enabled already, then it's great. If not, then again, might be harder to sell, right? Like, oh, you need to implement this plugin in order to get these queries fixed. Because scenarios where users can't change their queries are common, it is better to contemplate these on your query optimization system. So it's better if you include parameters. So the tuning engine is aware that any output or any recommendations around change in SQL are not useful or not feasible. So you can either disable them or tweak them, and again, and avoid sending your user things that they can't really implement. Taking this a step further, you can add a parameter so your user can specify if he's using some sort of well-known technology, again, a well-known platform like, as I said before, WordPress or Magento or Drupal, and you can have your own library of fixes or solutions for that specific technology. So you're not going to be recommending any query changes or any code changes, but you can point them to solutions that the community found for certain performance issues, or perhaps upgrades that would fix the problem, patches, etc. So these two would they aim to bring a better user experience, and again, avoid sending things to users that they really can't do anything with. All right, so wrapping up, automatic query tuning is about finding things you can do to make your query more efficient and speed up execution. And automatic means that we won't do all that without human intervention, right? You want to focus on recommendations that are simpler to implement. At the same time, they bring, they have higher chances of producing any differences or performance changes in a positive way. As I mentioned, query tuning can be direct or indirect. Indirect is when you aim to improve your overall server or host performance, but you're not really targeting any specific queries. And of course, direct is when you're actually looking to make changes that will benefit that specific case. Query performance can be improved by changing things at 3 levels: host, query, and database server. Recommendations that require changing the code are only useful if you are actually maintaining that, right? If maintaining the application is part of your business. Layer 7 proxies and rewrite plugins can perform query changes without code changes. They can do in-flight rewrites, so that they might be a workaround for implementing query recommendations without dealing with the code. And because it is common to have users that are not in charge of their apps, including options to contemplate these on your tuning system might be a good idea. So that's all I have for today. I hope you found this session interesting. And of course, if you want to get in touch and learn more about what we're doing around automatic query tuning, here's my contact information. Please don't hesitate to reach out. Thanks, and have a good one.